Imagine holding a piece of metal in your hand. A metal so powerful that a tiny amount of it can generate enough energy to power entire cities. A metal that helped humanity unlock a new age of technology, but also created one of the most destructive weapons ever known. This metal is uranium. For some people, the word uranium brings thoughts of nuclear power plants, radiation, and atomic bombs. For others, it sounds like something straight out of a science fiction movie. But what exactly is uranium? Where does it come from? Why is it so powerful? And how did a single element become one of the most important and controversial materials in human history? Let's find out. Our story begins in the year 1789. A German chemist named Martin Heinrich Klaproth was studying a strange mineral called pitchblende. While analyzing it, he discovered a completely new element. Excited by his finding, he named it uranium after the recently discovered planet Uranus. At the time, nobody realized how important this discovery would become. In fact, for more than a century, uranium was considered little more than an unusual material used to create colorful glass and ceramic glazes. People admired its bright yellow-green glow, but they had absolutely no idea that it possessed one of nature's most extraordinary secrets. Everything changed in 1896. French physicist Henri Becquerel accidentally discovered that uranium emitted invisible rays capable of exposing photographic plates. Without realizing it, he had uncovered a phenomenon that would revolutionize science forever: radioactivity. Soon afterwards, scientists Marie Curie and Pierre Curie expanded this groundbreaking research, opening the door to modern nuclear physics. For the first time, humanity began to understand that atoms weren't as stable and simple as they appeared. Inside them existed incredible amounts of hidden energy, and uranium was one of the keys to unlocking it. At first glance, uranium looks like an ordinary silvery gray metal, but appearances can be deceiving. Uranium is one of the heaviest naturally occurring elements on Earth. A chunk of pure uranium is nearly 19 times denser than water. Yet its true power isn't its weight, it's what's happening inside its atoms. Natural uranium contains two important isotopes: uranium-238 and uranium-235. While uranium-238 makes up more than 99% of natural uranium, uranium-235 is much rarer. And that tiny fraction changes everything. Because uranium-235 has a unique ability. It can split apart when struck by a neutron. This process is called nuclear fission, and when it happens, enormous amounts of energy are released. The energy released from splitting a single uranium atom is incredibly small. But here's the astonishing part. When trillions upon trillions of atoms split together, the result is almost unimaginable. A uranium fuel pellet no larger than your fingertip can produce as much energy as burning an entire ton of coal. Think about that for a moment. A tiny pellet equivalent to a mountain of fuel. This incredible energy density is why uranium became one of the most valuable resources in the modern world. Today, nuclear power plants around the world rely on uranium to generate electricity. Inside a reactor, uranium fuel rods are carefully arranged to control a chain reaction. As atoms split, they release heat. That heat turns water into steam. The steam spins massive turbines, and those turbines generate electricity for millions of homes and businesses. Unlike coal or oil, nuclear power produces electricity without releasing large amounts of carbon dioxide into the atmosphere. For this reason, many experts view uranium as an important tool in the fight against climate change. But as we'll soon see, its story isn't entirely positive. During World War II, scientists discovered that the same process capable of generating electricity could also be used to create devastating weapons. This realization led to one of the most secretive scientific projects in history, the Manhattan Project. After years of research and development, scientists produced the world's first atomic bombs. One of them, known as Little Boy, used highly enriched uranium as its fuel. When it was dropped on Hiroshima in 1945, the world changed forever. In a single moment, humanity witnessed the destructive power hidden inside the atom. From that day forward, uranium became more than just a scientific element. It became a symbol of both technological achievement and unimaginable destruction. Despite its power, uranium doesn't come from laboratories. It comes from the ground beneath our feet. Large uranium deposits can be found in countries such as Canada, Australia, Kazakhstan, and Namibia. The mining process begins by extracting uranium-rich ore from the Earth's crust. This ore is then processed into a concentrated powder known as yellowcake. From there, it can be converted into nuclear fuel for reactors or enriched for specialized applications. However, uranium mining is not without challenges. Environmental concerns, worker safety, and proper waste management remain major issues that require strict regulation and oversight. This is one of the most common questions people ask. The answer is more complex than many expect. Natural uranium is only weakly radioactive. In everyday situations, small amounts generally don't pose an immediate threat. However, prolonged exposure, inhalation of uranium dust, or contact with radioactive decay products can be harmful. That's why the nuclear industry follows extremely strict safety standards. Another controversial topic involves depleted uranium. Because of its extreme density, it has been used in military armor and armor-piercing ammunition. Supporters argue it's highly effective. Critics raise concerns about potential environmental and health effects. The debate continues even today. Uranium is one of the most fascinating elements ever discovered. It has powered cities, advanced science, changed warfare, and transformed the course of human history. It represents both humanity's greatest achievements and some of its most difficult responsibilities. As the world searches for cleaner and more sustainable energy solutions, uranium will remain at the center of an important conversation. A reminder that every powerful discovery comes with a choice: how we use it, and what kind of future we create because of it.